In section 7.2 we're looking at dividing polynomials or polynomial division. Now with this there are two methods. I'm going to run you through the method that the book uses first, and I'm expecting this to be quite a helpful video because this is one that is difficult to learn from a written example. It really helps to have somebody pointing out the different stages. Now first of all, before we start in on the first method, which is the method from the book, have a look at this. If I were to ask you to do 597 divided by 4, do you know how to do it this way, with this setting out? If you don't, I'm going to go through it now. If you understand that setting out, then you can scan forward until you see that I've started on the algebra. Because the algebraic method for polynomial division is the same as this method, which is sometimes called long division or the bus stop method or maybe the long bus stop method or something like that. So I'm going to do exactly the same question, and I'm just going to show you how I got all the bits and where all the bits came from. Now I'm not trying to insult your intelligence here. I'm sure you can all do 597 divided by 4 without a calculator in some manner or other, but this is the particular method which is useful to us. So before you start polynomial division, if you're not familiar with this method, I'd suggest you just practice 3 or 4 of these without a calculator. You know, it'll take you 5 minutes, but then you're doing the same steps for the polynomial division. So it goes like this: 597 divided by 4. How many 4s fit into 5? 1. 1 times 4, and the answer goes here. That's a 4. Then what was the remainder when the 4 went into 5? Well, 5 take away 4 is 1. Okay. How many 4s fit into 5 is 1. 1 times 4 is 4. 5 take away 4 is 1. Then I'm going to bring the 9 down. How many 4s fit into 19? 4. 4 times 4 is 16. 19 take away 16 is 3. Okay, you get the idea, I hope. 4 times 37 is 9. 9 times 4 is 36. 37 take away 36 is 1. Bring the 0 down, don't need the decimal point. How many 4s fit into 10 is 2. 2 times 4 is 8. 10 take away 8 is 2. Bring the 0 down. How many 4s fit into 20? 5. 5 times 4 is 20. 20 take away 20 is 0, and we've got a 0 here, so we know we've finished. Okay, so that is the bus stop long division method, and I suggest you practice that. Okay, because when we're doing polynomial division, we're going to use the same steps all the time. So first of all, let's just think about what we mean by polynomial division. We're being asked to do, in this case, x cubed plus 2x squared minus 17x plus 6 divided by x minus 3. And I'm going to set the divided by out straight away as a bus stop. Okay, so this is the example in example 2. Now what that means is, think about it as, you know that 24 divided by 6 is 4. Well, that's the same as saying 24 equals 4 times 6. Okay? With this polynomial, I've got x minus 3, that's a linear term. I'm going to have to times that by something to make it into x cubed plus 2x squared minus 17x plus 6. Okay, so x minus 3 times something equals this. What's the something? Well, the something is the answer to this divided by this. Okay, in the same way as 6 times something equals 24. What's the something? It's the answer to what you get when you do 24 divided by 6. So polynomial division you might think is a bit of an odd thing. We can only sort of deal with algebraic fractions. We're going to think of polynomial division as the inverse of polynomial multiplication, and polynomial multiplication is something we're familiar with. It's just expanding out brackets, right? Now that also helps us because we're expecting a quadratic, right? If we do a linear times a quadratic, we're going to get a cubic. So that should help us a little bit as well. Now this is how we're going to do it. We're going to do first term divided by first term, so x cubed divided by x. And that's the thing that we can do, right? X cubed divided by x, not a problem, x squared. Then what I've just written up here times by the whole of the thing in front here. So x squared times x minus 3 is x cubed. X squared times minus 3 is minus 3x squared. And then we do our subtraction. That take away that is 0. Now the first two terms, here we'll always have two terms on the go because we've got two terms at the front. We've written one term up here, so one term times these two terms gives us two terms here. When I do these two terms, take away these two terms, the first ones should always cancel out, and if they don't, we've made a mistake in the multiplication or the division somewhere. Okay, so 2x squared take away 3x squared is going to give us 5x squared. Bring down the next term, and then we do this thing here. So first term divided by first term, 5x squared divided by x is going to give us 5x. 5x times this is going to give me 5x squared. 5x times minus 3 minus 15x. Okay? And if you're following through, we just turn the page, I think. Yeah, we have. Minus 17x, 5x squared minus 5x squared vanishes out. Minus 17x minus 15x is going to give us minus 17x minus 15x. This term, take away this term, gives us minus 2x. Bring the 6 down. First term divided by first term gives me minus 2. This thing times this thing, we get minus 2x plus 6. That, take away that, gives me 0. I've got a 0, so I know I've finished, and there's no remainder. So I know that x minus 3 times by x squared plus 5x minus 2 equals x cubed plus 2x squared minus 17x plus 6. Okay? Or as they give it in the book, that cubic divided by that linear term equals that quadratic. Okay? Now, a couple of other things to point out with that method. First of all, I'm only going to do one example here. If I was in a lesson, I'd probably do 2 or 3 examples, but in a lesson, you don't have the chance to fast forward and rewind. So if that didn't make sense, just go back and rewind it. Get yourself used to all the stages. It's only a few stages, you recap them all the way through, you revisit them, you do them again. Now, here, in example 3, they've given us 4x cubed, take away 17x squared plus 4. Now this is a quartic, right? It's a power 4. So have you noticed we're missing the x cubed term? There's no x cubed term there. Now this method isn't going to work if we're missing a term. We need to have a constant, an x squared, an x cubed, an x to the power of 4, and we're missing the x cubed out. So what we need to do is just put it in, but there aren't any x cubes. So how do we put it in? Well, we put it in as a 0x cubed. So watch out for those ones. Make sure you've always got enough terms, all the terms that are supposed to be there. And if we do that, then here's the example, and it works it all the way through. And again, we get a 0 at the bottom, which means we've got a remainder of 0, so that division works. Now, here we have a problem because when we work the whole thing out, we get a minus 6 at the end. And we can't do minus 6 divided by x, right? First term divided by first term. We can't do that. Now, what's happened? Well, we can do minus 6 divided by x, but we get minus 6 over x, and that's not helpful for the rest of the process. Now, what's happened there is that we haven't got an exact sum. Now, that shouldn't bother us. It wouldn't bother us if I was doing, I did 24 divided by 6, and I got 4. If I did 24 divided by 5, I'm going to get 4 with a remainder of 4, okay? So there's no problem with division when I don't get a full answer, when I don't get an exact whole number answer. And of course, we haven't dealt with remainders for quite some time. We'd give that as a decimal or as a fraction. But with polynomial division, we're going to deal with remainders. So let me pick a different example so that we don't have the answer and the remainder the same. Let's say 25 divided by 4 is going to be 6, remainder 1. Okay. Now with polynomial division, it's often perfectly reasonable to just write it as they have here. The remainder is minus 6. But another way of thinking about this is that 25 equals 4 times 6 plus 1. Okay. So if you have a polynomial, we should be able to write that in the same way. So if I take the ones in example 4, so you might need to get your example 4. I can't get them both on the screen, I don't think. So page 141 if you're following it through. Example 4, they start with 2x cubed minus 5x squared minus 16x plus 10. We divide that by x minus 4, and we get the answer of 2x squared plus 3x minus 4, remainder minus 6. Okay? So one way is to just write it like that. Another way of doing that is the same thing here. When we had 25 divided by 4 equals 6, remainder 1. Well, 2x cubed minus 5x squared minus 16x plus 10 is x minus 4 times by 2x squared plus 3x minus 4. And then what did we have to do here? Well, we had to add the remainder on. Okay, so again, we'll add the remainder on. We have a minus 6. Okay, so when we say we've got a remainder, that's what we mean. We mean we can do the linear term times the quadratic in this case, because we're aiming for a cubic. So that one times that one. and then add the remainder. Okay? Now, this can get more fiddly, but you'll notice we're only being asked to use longer division to divide a polynomial by a term that looks like this, x plus or minus p. Okay, so we're only divided by a linear term. Now, if you're dealing with that, the remainder is always going to be a constant. If there is a remainder, it's always going to be a constant. So that's the sort of thing we need to be able to do. Now, you need to be used to putting your answer in either of these two ways, okay? One as a division with an answer and a remainder, and one as a multiplication plus the remainder equals the thing that we were dividing in the first place. And that is everything on the first method for polynomial division. Now I'm going to show you another method in the next video, which is one that I prefer but hardly anybody else does. So if you've practiced this method and you'd like to see another one, or maybe this one doesn't work for you, I'm going to show you another method that I like in the next video.